Hello, welcome to everyone in this video. This is our lecture number 12 of this series, that is the electronics theoretical part. In this video, I want to discuss about the feedback amplifier and op-amp. Actually, feedback amplifier we want to discuss in this video, and in upcoming session we will be discuss op-amp, operational amplifier. In this video, I want to cover up this portion, that is the effect of positive and negative feedback, and then voltage series, voltage shunt, current shunt feedback, and use for specific amplifier, estimation of the input impedance, output impedance, gain, stability, distortion, noise for voltage series feedback. So all these things are discussed, will be discussed in this lecture. Okay, so let's start. We can see this is the total syllabus of University of Calcutta 4th semester analog electronics. This portion, that is the circuit and network, already discussed. Semiconductor diodes and application discussed. Bipolar junction transistor, this portion also discussed. You can remark this 1 2, these 3 bipolar junction transistor, field effect transistor, FET, this also cover up. Regulated power supply also discussed, and this amplifier also discussed in last lectures. In this lecture we want to cover up this feedback amplifier portion, that is the portion A wants to this will be discussed in this lecture, and the upcoming session will be discuss operational amplifier and their application, etc, etc. So and the upcoming session will be discuss about multivibrator and oscillator. So let's look at this feedback amplifier. What do you mean by feedback amplifier? You know, this is the if this an amplifier, what happen if you give some input, you will be get some output with amplified, right? So if this output feeded into in, then what happen? This input will be increased and the corresponding output also increase. So in this way you can amplify this output with a small input. So with the help of this feedback amplifier you can recycling this output into feed into input, and the final output will be larger. Okay, so these are the motive for the feedback amplifier. So here the transfer of energy from output to input, such that a portion of the whole or the whole output feedback into the input signal, then amplification change. So the output is fed into in, this will be as a whole or is some partial part, that's not matter, but the output fed into in is the known as the feedback amplifier. So this is the only the amplifier, and this is the feedback amplifier. So as a whole this is the feedback amplifier, this is the amplifier, this is the feedback element. So as a whole you can say this is the feedback amplifier. This feedback amplifier generally two type: positive feedback, negative feedback. If the input will be in the same phase of the output, then the input will be increases, the amplifier enhance the input signal, then this is called positive feedback. That means when the output is fed into in and the final output will be increased, then this is positive feedback. And the reverse one, if this phase is the out of phase, then this will be reduces, then the output also reduce. That's why this is called negative feedback. But negative feedback is and some advantage like stability, less distortion compared to positive feedback. And for positive feedback, oscillator is a positive feedback. So there are use of negative feedback as well as for positive feedback depending upon our uses. Okay, so if you want to stabilize less distortion, you need to use negative feedback. Where you want to find out the oscillator, you need to use the positive feedback. So this is the purpose to use, where we use negative feedback, where we use positive feedback. Depending upon the use, you can use these two things. So look at the different type of feedback. This is a general diagram of a feedback amplifier. You can see this an amplifier A. This is input, this input change into output, and this output feeded back with this feedback amplifier into the input. So this feedback amplification is beta, then the beta will be VF, that is the VF is the here voltage and the V out is the here. So the the output of this feedback amplifier is this voltage and the input will be V out. That's why beta equals to VF by VO. So VF equals to beta VO. So the feedback fraction, which is known as feedback fraction or feedback ratio or reverse transfer ratio or reverse transmission factor. This is the same thing in the different name. This is the beta. This is Vf by Vo. Now this amplification is nothing but the output by input Vo by Vi. For positive feedback, this voltage will be added up. This input voltage will be added up with the Vs, and for negative voltage, feedback, this will be negative. This is depending upon which terminal is added up, out of phase or the in of phase. Okay. For positive feedback and the feedback gain as a total, if you want to find out gain, the output voltage and the input voltage is Vs. For positive feedback, this Vs is nothing but Vi minus Vf. So if you divide it by Vi, you will be get these things, and rearranging them, you will be find out A by 1 minus A beta. So AF equals to A by 1 minus A beta for the positive feedback. Okay. For negative feedback, similar things, the AF by Vs, but Vs is changes Vi plus Vf. So finally, you will get this thing A by 1 plus A beta. Okay. So for positive feedback, AF equals to A by 1 minus A beta. For negative feedback, AF equals to 1 A by 1 plus A beta. So AF greater than A and AF less than A. You can see this is a less than 1, so AF greater than A, and this is greater than 1, so this is AF less than A. So depending upon the this will be positive, otherwise this is negative feedback depending upon. So positive feedback, the gain with feedback is greater than gain without feedback, and in case of negative feedback, gain with feedback is less than gain without feedback. Okay. This term minus A beta is known as loop gain, because this is feedback, beta is feedback and A is the gain. Their multiplication is known as the loop gain loop, making this loop, because this make loop as a loop, this considered as a loop. Okay. And 1 plus A beta is the returned differential term, and A is the gain with feedback, that is closed loop gain, and A is the gain without feedback, this is known as open loop gain. So this is the different nomenclature you need to remember. And this is measured in dB decibel unit, that is 20 log AF by A. Okay. So AF by A is nothing but 1 by A plus A beta in the negative feedback. So feedback topology, there are four feedback topology, that is voltage series, voltage shunt, current series, current shunt. Okay. Voltage series means this output voltage fed into in the series condition. Okay. So the voltage sampling series mixing, this here this is a block diagram, and this is the actual diagram with the using of the transistor. Here this voltage is fed up, output voltage is fed up into the input portion. Okay. So the finally the C in actually used for the blocking the DC part and open for AC part. This is the output voltage fed into input voltage. So Vi is nothing but Vs minus V1 for negative feedback, and finally AF equals to like that. And in terms of transistor, the AF will be like that. Okay. In case of the voltage shunt, so this is voltage and shunt means parallel connected. So the current, you can see this is the voltage shunt, that is the output voltage fed into the input as a current, as a voltage source, that is the current. So Is, that is the series current, is nothing but If plus Ii. So If is equals to Vi minus Vo by Rf. Vi, this is the Vi minus Vo, that is this portion by Rf. So this will be minus Vf by Vi, which is Vi is very less. This is the reverse one. So If is proportional to voltage. So the feedback current is proportional to voltage. That why this is called voltage shunt. Okay. So current of this is depending upon the output voltage. That why because this is voltage shunt. Next is the current series. This is the current is cut off into this one and then connected into series condition. So in this diagram you can see this is the cell bias condition, and this voltage, that is VA, is nothing but RE at 0, R0 is constant. So VF is proportional to I0. So current is connected with as a voltage for negative feedback. And for fourth one is the current shunt. This is the current is connected into the parallel condition and in a shunt. So this will be the two cascading transistor. This is the output is connected with another input of the transistor. So finally you can see this is the IF equal to like that. Now if you want to find out the input impedance of this voltage series, voltage series, yes, voltage series, this one is the voltage series feedback. Okay, all are find out input impedance, output impedance for this one voltage series impedance. So input impedance nothing but the input voltage by input current. So the input impedance with feedback, so this Vs by Ii. So Vs is nothing but Vi plus Vf. So Vf is beta Vo. So Vo is a Bi. So you will be get this one. So this is the impedance with feedback is greater than impedance without feedback. Input impedance. And the next one is the output impedance. Signal voltage is 0, disconnected load resistance RL, current voltage source V at load terminal, and the current delivered by the voltage source V in the absence of feedback, Z0 equal to V by I prime. So feedback present, when feedback present, finally you will be get this one. So output impedance is less than the output impedance without feedback. Gain and stability, if you want to find out the gain, you can see the gain with feedback is AF equals to A by 1 plus A beta. Just we find out this relation. If you change this, if you take derivative of this relation, you will be get this one. So you can see this is nothing but this one. So this change, this sensitivity, if you find out the sensitivity, the F by A, so this is nothing one. So you can see this is greater than 1, so this will be less than 1. So sensitivity is less than 1, so this sensitivity will be 1 by this one. So D is greater than for negative feedback and gain stability is better. Distortion, you can see if there is a distortion in your input. Suppose this is a input, that is the distortion here input. So if you amplify for positive feedback, the distortion also amplified. Okay, so distortion will be increased in positive feedback. In negative feedback, this will be reduces. Distortion will be reduces. Okay, and the noise also similarly thing. For in case of frequency distribution, you can see low frequency amplification. This one high frequency amplification with feedback. This will be changed. Will be like that. So this without feedback, this is the amplification, and this. So the band will be increased with the feedback circuit. For negative feedback, obviously negative feedback we use. In case of some phase distortion also, will be get the negative phase distortion gain by 5. Some change will be happening here. Okay, and the effect in negative feedback. So finally we can conclude that using the negative feedback you will be get reduced gain but stabilized, reduced distortion. Both with of amplification can increase frequency distortion reduced, phase distortion reduced, input output impedance can be changed suitably. So this is the effect of the negative feedback, and this is the benefits of the negative feedback. Only the benefit of the positive feedback is the oscillator, we will be discussed in the later one. So I think clear all about this. If there is any doubt, you must comment in the comment box. This is all about me. This is my contact detail. You can connect with me. It is Telegram channel. This is my online platform, and this is my contact YouTube channel details. Go to this channel. You will get different physics related video and some mathematics. But like this session, if you learn something from this session, share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get notification of upcoming videos. So take care. We'll meet in the next video as soon as possible. Thank you.